Today, let's verify trig identities. This is great pre-calc review. Let's go over the identities first. I'm also going to make some adjustments to a couple of these because personally I find it easier to remember two of these identities in front of us if they're just formatted a little bit differently. All right, let's go with the simple ones. We know that tangent theta can be rewritten as sine over cosine. And by the way, I'm using a symbol called theta. It's a Greek letter representing an angle. If you have the letter x, you can use the letter x. So if you have tangent x equals sine x over cosine x, that's cool. You could keep it that way. Continuing, we have cotangent of theta. That's going to equal to the opposite of tangent. You notice how it's cosine over sine? So that's kind of easy to remember. Tangent and cotangent are opposites, which is why I also brought up this. Cotangent can also be rewritten as 1 over tangent. All right, so let's move on to secant. Secant is just 1 over cosine. A lot of people think it's 1 over sine because it starts with an S, but be careful, it's actually the opposite. So secant starts with an S, it's 1 over cosine with the C. You'll see with cosecant, right, it starts with a C. In the denominator, you'll have sine. So cosecant equals 1 over sine. Those are the basic identities that we could use. For the more advanced ones, let's talk about what's happening here. We're adding two different trig functions. The key giveaway, all right, the dead giveaway is that plus sign. Whenever we see a plus or a minus sign in any of these verification problems, you should be alerted that you're probably going to use one of these three identities. We have sine squared plus cosine squared equals 1, which can be rewritten in plenty of ways. We'll practice that. We have 1 plus tangent squared equals secant squared. 1 plus cotangent squared equals cosecant squared. These last two here are the ones that I want to rewrite very briefly to make them a little bit easier to remember. I like the format of the first one, the sine squared plus cosine squared. I want to follow that so that's easier for me to remember these other two. All I'm going to do is rearrange the equation. I can subtract tangent squared on both sides. Okay, and if I do that, I'll be left with the result of 1 equals secant squared minus tangent squared. And that's the identity that I actually want to keep. So I'm going to erase my original writing. And I'm going to put 1 equals secant squared theta minus tangent squared theta. Okay, I find this way more easy to remember, and I could still use algebra to move it around, which we'll work on together. I do the same one with this, with the cotangent. So we get 1 equals cosecant squared theta minus cotangent squared theta. All right, and I could erase what I have in the black marker down here. Again, I just rewrote those identities. I didn't change anything. I just rewrote them. I subtracted the function to the other side. All right, so as I erase this, let's jump into the methods that we're going to prioritize as we verify these things. These are just little tips and tricks that I use in my own mind to help me quickly get through these verification problems because it could be overwhelming. It feels like a different language at times. It's not about numbers, it's about the trig functions and how they can transform. So here's what I try to prioritize. First things first is try to convert whatever trig functions you have into sine and cosine. All right, that could help a lot. It could help tremendously. You might be introducing fractions, but it's not going to be the end of the world. You're going to want to typically go to sine and cosine. If that doesn't work, you want to look out for combining fractions. And that usually comes up when you see a plus or a minus sign. When you see that, you're typically going to have to use an LCD method to combine fractions when you're adding or subtracting them. Again, we'll get to that. And then lastly, I want to try to use a pencil for my work and a pen for referencing the identities that I just showed you guys. The identities that hopefully you wrote down yourself. Obviously, I have markers, so I'll just use different colored markers instead. Let me see. All right, doing good. Let's jump into the first problem. Whoops. Cosecant theta times cosine theta equals cotangent theta. All right, we have to verify this. That's what all of these problems are going to be, verifying the identities. We're not solving for theta or x. We're just trying to match the sides. We have to get one of these sides to match the other one. And you could choose. That's your first decision as a student. Do you want to start on the right-hand side or the left-hand side? As I mentioned before, I try to focus on the more complicated side. So I try to focus on that side first, and I try to simplify that down rather than taking the smaller side or the easier looking side and expanding it. I don't like to expand. I like to rather just simplify and condense. So I do switch left and right side. Some people like to stick with the left hand side, and that's okay if that works for you. I like to flip-flop with whatever they give me as a problem. So let's convert these into sine and cosine. We have cosecant, which I know cosecant is 1 over sine, right? And so this is what I'm talking about with the pencil and pen. With my blue marker, I'll treat that as my pen. I would write this off to the side. I'm not doing any work. I'm just kind of like shouting out what I know is a proven identity. So what I could do with my work is I could rewrite the cosecant as that fraction. Sounds like I'm doing more work than I need to, but watch how this simplifies. So I wrote the cosine theta as a fraction because I need to multiply these terms together. At this point in time, we would multiply across, straight across. That's how you multiply fractions. So we're going to have cosine theta over sine theta equals cotangent theta. And we're looking good. This in itself is one of the identities that I showed you. The proper final answer is to actually write it as cotangent theta equals cotangent theta. So for example, for this last step here, if you wanted to, you could have written cotangent theta equals cosine over sine, right? So it's good to use this method because it helps you memorize all of these identities. If you're just starting off, it's going to be very overwhelming. Use your pen and put these to the side, maybe in the margins of your notebook paper, for example, and that's going to help you memorize these things. The more you write it down, the better. And so just like that, we verified that identity. Let's try the next problem. We have, let's do sine theta cotangent theta secant theta equals 1. Okay, there's a lot going on, but don't get overwhelmed. We know that we want to try to convert these things into sine and cosine. We're good with the first term, but however, cotangent, I'm sorry, it's COT, is 1 over tangent or cosine over sine, right? Let's go ahead and skip the 1 over tangent and let's just plug in the cosine over sine. So we'll have sine theta times cosine over sine. I'm going to put in my little variables. All right, so, and then the secant, do you remember what that equals? 1 over cosine theta. So I can rewrite that. 1 over cosine theta equals 1. We have to continue until the left side matches that right side. Let's combine these fractions. How about we rewrite that sine theta, the first one? Let's rewrite it as a fraction. Sine theta over 1. So that way we know we could just multiply straight across for all three terms, all three of these groups. We could just combine all of them together. Whatever's on top stays on top. So that's sine theta cosine theta, and then the 1, which I'm not going to write. Down below we have the 1 sine theta cosine theta. Again, all this is equal to 1. Don't forget that. Don't forget the other side of the equation. Okay, hopefully now you can see that the sines cancel and the cosines cancel entirely. So we're left with 1 equals 1. So that last step didn't even really require any more references to the identities. You just have to practice understanding how to simplify that fraction. And that's how you verified that identity. Let's do tangent theta equals cosine secant over cotangent. Right, so if you're one of those people that gets stuck on the left-hand side, that's okay. You're going to have to expand tangent into this fraction, but that's not how I work. I want to look at the right-hand side now and work on that side. So the cosine I'll keep. How about the secant can be rewritten as 1 over cosine. And then the cotangent can be rewritten as 1 over tangent. Now, the reason why I'm keeping this as tangent in this case is because I have a tangent on the left-hand side, so it's a little bit of a red flag. Let's go ahead and plug these values into this fraction that we have, and then I'll show you how to manipulate it. Cosine times 1 over cosine is all in the numerator. Down below, I have 1 over tangent theta. All right, all I did, guys, is I just replaced the secant and the cotangent with these variables, or with these identities, these replacements, if you will. Now, in the numerator, we can simplify that. Cosine times 1 over cosine, that's just 1. So essentially, that kind of cancels out. Let me use my blue marker for this. I could just replace that whole numerator with just the number 1. Now I'm left with tangent theta equals 1 over tangent theta. So how do I handle this? This is great fraction practice, so I'll go over this kind of briefly. We can rewrite this as 1 divided by 1 over tangent theta. Remember that a fraction bar is just a division symbol, basically. And at this point in time, I could practice keep, change, flip. I'm sure you remember this from elementary school. Keep, change, flip. We're going to keep the 1, change the division to multiplication, and then flip the fraction. Tangent theta over 1. Okay? Now, anything times 1 and divided by 1 is just itself. So, we have tangent theta equals tangent theta. You see how these 1s, nothing really happens. Nothing really comes about with these 1s. We don't really need those anymore. However, what was important about what I did with the keep, change, flip, and the reason why I rewrote this fraction, is so that I could properly flip this fraction down below, the denominator. You see, in the denominator, there's a fraction in itself. So instead of getting overwhelmed, I practiced the keep, change, flip, and I rewrote the fraction as a division sign. That's what helped me get to tangent theta equals tangent theta as my final answer. All right, we're doing good so far. Let's jump into the other more advanced properties, the identities. Let's do 1 minus cosine squared, and these are parentheses. Okay, put those in parentheses, and then times cosecant squared equals 1. All right, so I'm going to reference the identity that said sine squared plus cosine squared equals 1. Whoops. Is that what I have here? No, not necessarily, but I could rearrange this identity to match what they have here. I can, for example, subtract both sides by the cosine squared. You are allowed to do that. That gives you sine squared equals 1 minus cosine squared. Now that looks familiar, right? That's exactly what we have in our problem here. Okay, so you have to understand that you could replace the 1 minus cosine squared with just a sine squared. Okay, because we just proved that this is equal to sine squared. That's all I've done so far. I just replaced that. Now I want to convert my cosecant squared into some sort of sine or cosine, right? So let's reference that. Cosecant equals 1 over sine. So you might ask yourself, this is cosecant squared. So where does that help me out? Do I have to use the other problems with the plus or minus sign? No. So even though we have a cosecant squared, we could basically just rewrite our original identity with the same exponent, with just a matching exponent. Cosecant squared equals 1 over sine squared. Okay? So again, this is the identity that we started off with in the beginning of the video, and we could rewrite it as cosecant squared equals 1 over sine squared. We are allowed to do that. So I know that this cosecant is going to be rewritten as this fraction over here. Sine squared theta times 1 over sine squared theta. Okay, we're going to combine. All right, the sine squared on the outside goes to the top. I'm sure you see where this goes. You see how it all falls into, it all falls into place relatively quickly. The signs cancel, giving you 1 equals 1. Okay, not too bad, not too scary. Again, if you're just starting off, of course, it's going to be intimidating. But please practice this method where you're using a pencil for your actual work and then a pen for your identity references. So let's do cosine squared times secant squared equals 1. Oh, wait, we did that. Wait, did we do that? No, we didn't. Cosine squared, secant squared equals 1. Right, so secant squared is equal to what? Hopefully you remember it's 1 over cosine squared. Again, we're referencing the secant equals 1 over cosine identity, but we are allowed to apply that matching exponent. So when we plug that in, we get cosine squared times 1 over cosine squared. All right, you see how we're practicing that same method over and over again? These are going to be some recurring themes that you'll see. So cosine squared over cosine squared equals 1. Replace that with a 1 on the left-hand side, and there you go. All right, let's see what else we got. 1 minus sine squared, 1 minus cosine squared equals cotangent squared. Right, so now the 1 minus sine, 1 minus cosine, as I mentioned, I said, oh, you usually want to convert into sine and cosine. That's not going to help me out though. I can't convert this into sine and cosine. That's not really going to be too helpful. So let's try to relate the addition properties that we worked with, the more advanced ones. We know that sine squared, whoops, let me grab my blue marker. Sine squared plus cosine squared equals 1. Again, I could rewrite this. So let's try to match the 1 minus sign. I'm going to subtract sine squared on both sides. We get cosine squared equals 1 minus sine squared. Okay, so now I can identify that this numerator is just cosine squared. I'm going to start off with that. All right, now let's focus on the 1 minus cosine squared. We did this earlier. We could do it again. We would just subtract cosine squared to both sides of the same identity. You notice how we're using the same identity twice? That's my work shown for the first time, and then now I can subtract cosine squared for this attempt. We know it's sine squared. So we know we could put a sine squared down below. All right, so how do we connect this fraction into this simple trig function? Well, remember cotangent equals cosine over sine. We can still apply that exponent rule that I mentioned to this identity as well. Cotangent squared equals cosine squared over sine squared. Don't get overwhelmed by these exponents. So basically this left-hand side could be rewritten as cotangent squared. And that's how we verify that identity. Some of the harder identity verification problems are going to include 3, maybe even 4 identity references. All right, last one for the day. Secant minus cosine equals tangent times sine. Right, so quite the dilemma whether you want to start on the left hand or right hand side. Personally, I can't stand seeing that minus sign. I find that to be complicated, a little bit overwhelming. I know I could probably translate this fairly easily, but I feel like I would have to expand it somehow into 2 different terms. So I'm going to leave the right hand side alone. I'm going to focus on the left hand side. Secant is 1 over cosine. So that's my first step. Now, for the sake of just some foresight, all right, a little bit of foreshadowing, we have to combine these 2 terms here. In order to combine these 2 terms, I need to make this right-hand term a fraction. So that's why I'm going to put it over 1. Now, to combine fractions that are separated with a plus or minus sign, you have to have a matching denominator. And you could do that by focusing on the LCD. Now, the LCD between these 2 fractions is going to be cosine theta. All right, I do have LCD practice problems in other videos. I'm not going to focus too much on that. I know that this fraction on the right-hand side needs to have a denominator of cosine. So what I'm going to do is I'm going to take the fraction and multiply the top and bottom by cosine, because I need that denominator to become cosine. So I have to do the same thing to the top though. So check this out. 1 over cosine theta, that's my first term, minus cosine squared theta over cosine theta. And don't forget the other side of the equation. Okay, now I can combine this fraction. When you combine the fraction with a plus or minus sign, you don't change the denominator. You just combine whatever's up top. So you see I have 1 minus cosine squared up top and a cosine theta in the denominator. So, do you remember what 1 minus cosine squared is by now? If not, that's okay. Let's use this identity that involves the sine squared and cosine squared. We know that when we add them together, it equals 1. And we have 1 minus cosine, so let's subtract cosine to both sides. We know that sine squared equals 1 minus cosine squared. Okay, so I could replace that with a sine squared. I'll erase the top half. Sine squared theta over cosine theta equals tangent theta sine theta. All right, we're making good progress. We have to somehow get a tangent extracted out of this fraction, which is possible. I can factor out a sine from the top, from the numerator. So that'd be sine theta times sine theta over cosine theta. Again, all I did was pull out one sine. The exponent tells me that there's 2 of them. It's sine squared. So this is okay. We're not breaking any rules here. This is important, however, because it's sine theta over cosine theta, as we'll reference it over here, is equal to tangent theta. So I can replace that parenthesis with just tangent. Sine theta tangent theta equals tangent theta sine theta. The order doesn't matter. You can use the commutative property to just swap them around. So basically that left-hand side, you can just rewrite that as tangent theta sine theta. And just like that, we have a perfectly matching left and right-hand side. All right, if you stuck through that whole thing, great job. I know verifying these identities can be pretty difficult, but just keep going at it. Keep putting pencil to paper, pen to paper. Keep writing these problems down and trying them over and over again. Use this video as an answer key if you need to. Try them on your own, maybe tomorrow, for example, and then compare your answers tomorrow to what this video shows, and that way you could see the right way to do it. But it's good to give yourself a break and then try it all on your own and then review some answer key of some sort. All right, great job, guys. Request any other math topics down below in the comments. Thank you for supporting. Subscribe, hit the bell so you see the next video. And again, thank you.